Hey, what's up? What's going on? It's Papa Bale. Welcome to the live stream here. And we're looking at a 120-degree pulse motor with three trigger strands, one for each coil, and it's running series connected trifectas. So we get 20 gauge, 22 gauge. So you get 22 gauge, you get 30 gauge, and you get 26 gauge. So 22, 26, 30 connected in series, and you got a 32 gauge trigger strand, which works perfectly. You can see there's no problems there. Yeah. All right. So what I wanted to discuss is, the 369. What it is we want to get gather from it. It's vortex math, and it's used to create certain coils. But here, let's just look at it this way for just a second. I got 9 magnets on the rotor. Okay, 40 degrees of separation on the rotor. And I want to make 3 more coils that are pretty much identical to these ones, and put them in the offset positions. So you have 6 coils, and there's 3 strands in each coil that are hooked to the drive. So there you go, there's another 369 kind of thing. But if you look at it from another perspective of less is more, the more I put on this thing, the less it's going to function. The more intricate it's going to be, the easier it's going to break down, basically. Now there's 2 other ways that I've connected these coils. One is going 22 connected in series to this 22, connected in series to this 22 to a transistor. So that's one parallel 22 strand. Then I hooked all the 26s together in series, hooked it up to a transistor that's 26 and 22 in parallel. That's why I call it parallel, even though it's been hooked up in series. And then the 30 the same way. And that way it picks up like really, really slow, but it'll get going like just as fast eventually as any way you hook this up. It's basically the amount of torque that's involved, depending on how you connect the wires. See, when I hook them all in parallel in their own coils with their own, that's 9 transistors altogether. It hits really freaking hard, man, and it gets going speed really fast. Like that. It's like that, literally like that. But, I burn out transistors all the time with that. And these are my resistors right here. The 100 volt, 200 ohms, 5% resistance. And my stuff is still blowing up. It was like, and what it was, honestly, I had one of these set and one offset. So I had one right here at 180 degrees, because there's 9 magnets on the rotor. You can do that when you set and offset. It got going so fast, even with the fast switching transistors, that they blew out just from going so fast. There's no other way it could happen. Maybe it's because the voltage literally got so high that it went through the resistor, or something crazy like that, because one of them just burnt out from it going so fast. And I don't know, like, and it wasn't that it was going fast, it's that the frequency, because there's 9 magnets on the rotor, I don't know. I really don't know, because it could have only been about 120, maybe. Anyway, I got this, I had this, oscilloscope, and I got the scope, man, it's right here. And we're gonna hook it up to, I have these 3 connects right here. One's connected to the emitter of this transistor, one's connected to the base, one's connected to the collector. We're gonna check that out on the scope. Alright, so we'll clip this to this end. And this is going to be the emitter. Wow, does it even work that way? It might not work that way. You got nothing on the emitter. So let's put this up here like this. Now, well, actually, I might actually have to go get a clip. My God, I've been actually keeping track, trying to pick up after myself. As he closes the door. All right. And we need the black one. Where's the black one at? Right here. All right. We're going to hook this to the ground. And we're going to get maybe some more accurate readings. All right. So there's nothing coming out of the emitter. Look at that. That's out of the collector. That's hooking the oscilloscope to the collector. You might have heard it change a little bit. Maybe I'll zoom in on that. And that's just that one coil. So I'm pretty sure it's like, actually, let me take it out. I don't want to screw it up though. Anyway, that wave kind of looks like that. That's as close as that's going to get. Yeah, I guess I'll take it out of here. I want you to see the numbers on that. That's why I'm taking it out. And they're all set right now. They're all hitting magnets at the same time. Sorry, I'm so shaky. Really don't mean to be that way. But see, that frequency is very low. All right, I got an idea. I'll probably be just as shaky, but I have a selfie stick here. Yeah, I'm not going to be able to hold this steady. Hi, how you doing? So one of the things I wanted to discuss was making the other 3 coils. I got to take this out of here, man. I can't hold it still. I'm going to put it back in the tripod real quick. Sorry, I really apologize. All right, so yeah, look at those readings. I took it out of here so you could see the readings better, but I don't even know if you could see them better with me shaking like that. Oh yeah, that's not good. Here, let me move the oscilloscope. Let me hold it like this, see if I can't get it close enough. Still gonna shake, but that's a collector reading. Hooked up to the collector of the transistor. Oh my god, wow. I thought that was pretty neat because I've seen the one with 4 magnets and it's really simple. This one is not simple. It's not, I wouldn't say it's necessarily strong, but it's vibrant. It's very vibrant. But that frequency is low. I mean, it's higher than what's coming out of the wall, but I mean that's not what I was expecting. All right. And now we're going to hook it up to the base. The moment we've all been waiting for. Actually, I think I just. What did I just do? Oh, that collector might be fried. That one is hooked up to right now. I put all the. See, that's the thing about MPNs. When you touch the collector when it's lit, that's not good. And I would say that is, you know, good, but it's not. One of them isn't working. It's working good though. I'm not saying it's not working. I'm just saying it's not working as good as it could. So let me look here. it going? All right, so.
We're doing live?
Yeah.
Okay.
And I had a feeling that that might happen doing that. Anyway, let me just hook it back up to you. Oh, it's still connected. Yeah. Throw your hands in the air if there's a true player. All right, here we go. Let's hit the button. Yeah, it's back. All right, sweet. It was the clip. These clips are like built from just above plastic material that's very breakable and bendable. And when they bend, they don't really clip right. So it is working. Everything's working just fine. It's just when the wires cross, if a wire crosses and the metal touches metal when it's not supposed to, you'll see the results. But I love that sound. You love that sound? So what I was thinking, and I really want to discuss this, was making 3 more coils virtually identical to these, except in these ones we're going to have 20 gauge instead of 22 gauge. So 20 gauge, 26 gauge, and 30 gauge in this position and the positions right here. So virtually like a hexagonal. Awesome. Yeah. So there is no offset coil right now. This is all hitting on set. Sorry, I could run this with one trigger strand if I wanted to. And I was just running the parallel series circuit, so I hooked all the strands up to themselves in series, and I hooked them up to the 3 transistors over there. And it took a long time for it to get started because I only had like the 1 trigger coil. I don't know what was really going on that made it so slow. But it got up to speed, just like this one, gets up to speed. This one goes faster now. This one gets up there faster. But if you let it run long enough, they're all going to get up to the same speed. And they're going to hit a plateau. And I think I don't know what that's from. It might be the bearings, actually. It could be something really simple like that. And I don't mind. I think this is awesome. This is moving great, in my opinion. I bet it's going maybe 600. Nope, not even. 421.8. So, if I got the offset coil in there, I bet it would work even better. But what's really going on, I think, is I'm using different transistors. These are high switching transistors. I need a little bit more voltage. And just one of these coils in parallel, just one, Works really, really well. And I might even set that up before we go. Nice. What are you getting? Heck yeah. Here, let's take a look this up here again. Let's see if the light. Yeah, the light is definitely. Look at how high those spikes are going, but they're only. And I'm pretty sure this is because the magnets are all going the same way, and the electromagnets are all going the same way right now. Everything's kind of going the same way, and repelling each other. And this is the result, I think, on the oscilloscope. I think that's what's happening. It's all positive. It's all. And if I hooked it in the other way, it would read the other way, but that's backwards. Because that's the opposite way I hooked it up. Okay, my man, and what is that exactly? Is it a component? Is it a printer? What is it? See, look at how fast and like the torque is good. Gets going again really good. Alright, so and I swear to God, I don't know if it's true because it's been so long since I actually did the parallel in one coil parallel. If it's better, but I mean this is great. This hookup is all the coils are hooked into a series into themselves down to the 30. And the 32 gauge is a trigger for each one of these, so they're all hooked in series into themselves. And they're all individual placements. I can move them if I want to, and they kind of function the same way. Yeah, I don't know, man. I tried to show some people in my audience some readings, and it didn't go so well. I'm shaking really bad right now. So. But anyway, it's like 450 volt spikes, but there's like 9 of them. There's several of them per strand. I mean, you can see them right there. No, you can't, because the freaking light. Let's see if we can use the outdoor light so you can see it. Maybe that'll work. Oh man. Okay, I can't change anything because my phone, the screen popped in, and I'm not going to take it out of the You can see the oscilloscope reading a lot better without that bearing on. So I'm going to get maybe I'll move the tripod around a little bit. This is awesome. Oh yeah, there's this one little like I'm making some headway on that magnetic sculpture thing. Once I get the bearings for these ones on the side here, you can't really see it. Yeah, I got that one. I was just looking for one that I could understand and use and make it actually work and everything. And I ended up with this one, and this one works really well. So, sorry I can't zoom in. I'll let you see the numbers. But yeah, it's the 120-degree circuit. And I'm going to do it in the reverse mode, so you're going to have the blade and the cup, like there. So we're going to have two up here and one down here at the base, and just do it over again for the offset. And the reason that will work is because there's 9 magnets on the rotor. I keep on putting emphasis on the odd magnets on the rotor is really good for like doing that set and offset kind of thing. Or having and that way one of your triangles is always going to be functioning. There's not going to be any like gaps in your wave there. It's always going to have lines going through it and gaps. Well, I mean, in the complete, I don't even know if you can get a reading of the complete thing, but I mean, for that coil, I think this reading will always be the same. It will always have the gap because it's just the one coil. But like the machine itself, once you get all that together, it will always be on. It won't be an off, and it'll work. Anyway, this is how good this one works. And when I get the bearings, those should move relatively smoothly. Let me take this off of here. All these magnets, top, bottom, sides, are all facing north. North is sticking up. So when these two come together, this bottom and this top one, you get a strong south right there. Everything else is north except the corners of these rotors. These little rotors, which happen to be squares. So very attractive at the corners, and everything else is repelling. So just an added boost in between. Yeah, man, I can't wait to get those bearings. They're needle bearings, needle something bearings. And they fit right in those little holes. And they fit right around these 3mm holes. These are 3mm right here. These are really small. And you gotta like kind of hammer them in the holes in the base. I already bent one of them. There's very, I mean, literally, there's not much voltage going through this. When I hooked it up the other way, when I hooked it up going all parallel, all the way around, so parallel series, there were two strands left over here. There were the two 32 gauge strands. So I hooked them in series. Just hooked them together. And I sent them through two capacitors. And it had a relatively similar design to this one right here. It was a little shorter, a little wider, because I think there was not only induction going on, but EMF going on. Because it's like in the coil itself, so I don't know, maybe. So it was elongated, so it was wider this way. Wow, okay, 17 volts going through the collector. 17 and a half. But I can't do that with this setup because both of those strands are being used as triggers at the moment. But it was pretty neat, and I wound it through and I put it back into the positive part of the terminal block over here, the power distribution block. So I put it right on top of that green wire. And as long, it's funny. It helps kind of, it changes the frequency entirely. The sound going through this thing changes drastically. And it continues to function. I'm not sure, I'm sure it slowed down a little bit. It just sounded that way. Everything kind of sounded a little bit slower. But it continued to move. What am I getting at? It's alright. Oh yeah, the effect of the two strands on the rest of the machine, like putting it back into itself. I wouldn't advise doing that. I mean, it doesn't function the way you think it will. In this case, it continued to work, but it had the opposite effect that you would assume putting more voltage in would have. And I don't think anything really happened, but I mean, and then when I tried to start it with it already hooked up, because I did that mid-operation, it wouldn't start. So it's obviously a load of some kind. Absolutely, man. The rotor and the motor itself is the load, because that's just where I hooked it up to. Like, the beginning of the power distribution, so it went to all the coils. I thought it was pretty cool though. It continued to function, so yeah, I consider that a win. It's not, it's not practical. But I'm going to have a blast putting this little thing together, man. This is going to be awesome. Yeah, like I keep saying, man, once I get those bearings in there. Whew. So yeah, I guess like the next live stream I do, those coils should be done. Unless it's another one today, I'll let it on. That's awesome. This is great. $491.2. I'm thinking I'm going to almost double the RPMs once I put the offset coils on. And seriously, if I did this with the Hall effect sensor, I'm thinking that my output would be increased by at least 400 RPMs. Because there's just optimal manipulation you need to do with the trigger coil to get it to function optimally. And just because it's working doesn't mean it can't make better. You know? And I'm running into that a lot because, you know me, I just like putting it together, and if it works, that's a win. But you know, I'm starting to get a little bit more picky about my own work. And I'm hoping this will function the way I want it to. This little thing over here. I can get it all within that 7-inch space. That'll be spectacular. But this is how it works, man. There's this toroid magnet right here. And then the rotor sits on top of that. And it goes north-south, so it has both. I might not even have to put the side magnets in there, but I'm putting them in there for aesthetics. And this next one over here is going to be above that one, so it's going to be sitting up here. And hopefully we can get it so the magnets interact enough to spin it. The next one. Everything's looking straight up so far. There aren't any bent poles or anything crazy going on here. Oh man, I wonder what I should do. Should I just hook it up in parallel, or should I move one of these to the offset position right now? Probably not. I'll just leave them where they're at. So I got a shipment of transistors coming in with a fast switching time. The kind of using now. We got to put a little bit more voltage in, but the output is, you know, exponential compared to the tip 142s. Alright, and then when I turn it all the way off, and it says 17.1 on the meter over there. Hey, Mr. Jake, what's up, my man? I mean, yeah, if you want to, like, electrocute yourself, like, accidentally, by touching a hot wire or something. It'll wake you up in the morning, I'll tell you that much. But I was just getting done saying that these coil spreads, oh man, okay, it's all good. That's right. I'm gonna move this one at 180 degrees right now. We're gonna see if there's a change, but this is gonna shift the balance a little bit. Oh man, I wish that I had my glue gun plugged in right now. I can't hear you.
Oh, can you bring me some duct tape?
Yeah, there's right there next to the chair.
This?
Yeah, the gray stuff.
Okay, I got it.
All right. I'm gonna give that a few minutes. That really, I usually always have that plugged in. What does that even mean? That's not what it is, but I mean, that might be what it is, but it's not run like that would be run, because I'm pretty sure those coils are unilateral. And it may run better or more efficiently even. And I'm pretty sure the sine wave on one of those motors is going to be pretty level and even. I'm pretty sure there's north-south going on in most of those. But I don't know, maybe it is. I always say it's a magnetic induction motor. I mean, I'm not trying to steal anybody's thunder or anything. And I believe that goes back to Faraday. And I've always said that. And I guarantee you there's very little energy going on in this thing. That's the surprising part. I mean, I might have to turn a little bit of voltage up, but this power supply that I have hooked up has a max of 8 amps that it will allow to go through it. Oh, the flux capacitor, dude? Yeah, man, I always like to say that. And you're right, because of the triangle design, the 120 degrees. Thank you, Mr. Jake. Thank you. I appreciate that. Oh, that's so cool. And what we're going to do is we're going to have a flux capacitor, and then we're going to have another flux capacitor upside down right on top of that. You know what I mean? So I'm just going to hook up one of those coils for the upside down one, and leave 2 of the coils, because I haven't made any of the other coils yet. And they're actually going to have to be 2 gauges off, because I don't have any more 22. I can't buy any more 22, but I have enough 20 to make 3 coils. Oh, I didn't even think of that. 3 coils. All right, so there's 538.8 turns in each one of these coils. I could step down, I could start it at 26, do a 30, and then, no, that's way. I believe that's the incorrect question. I'm not trying to do anything. What I'm going to do is I'm going to see the effects. After I glue this one down, right now, we're going to see the effects of having a set and an offset coil at the same time. That's what we're trying to do right now. But it's always about right now, man. I don't have an end goal, if that's what you were wondering. We're just going to see what happens. If you were here, you saw how fast it was going with the 3 on the same tick, basically. But
the tick's find its way inside here.
all right, so I'm going to attempt to do this. Oh, this is really unnerving, but the glue is ready. So it's not perfectly balanced because we still have the second one in the set position. Now I can take that transistor out. Here, let me move it back over a little bit. So that's what we're looking at right now. Yeah, exactly. It's a basic magnetic induction motor made with radial coils without a core, using high-speed switching and a 9-magnet rotor, and there will soon be 6 coils of the same basic design, and then made out of 3 strands, which will be triggering, and 1 strand to trigger the coils. What I'm doing is I'm just using 3 strands, 1 in each coil, and I hook the positive end of the strand up to the base, the negative strand up to the ground, and send it through a resistor. And these are the resistors that I'm using. Right here. So yeah, I guess it's a loop. Is that what you would call it, an open loop? Where the coil is actually kind of triggering itself. I wound an inductor into it that would trigger the base. All right. Let's just turn this on. Hopefully no wires are touching. Now I was told that this would immediately add speed and torque, because there wouldn't be an on-off going on. It would always be on. Now, if I'm right, the last time that would continuously increase in speed up until the point where the transistor yeah. Well, I mean, it's so easy. It should be common. But what I don't think is common is to have all the different gauges in the same coil. Is not common. I don't see it anywhere. And if you have literally more than 1 coil, you can do a parallel and a series in the same circuit. Kind of like hooking up a capacitor bank. that charges itself pretty much. Of course, they're always going to stop running. They're always going to die. Eventually, everything does. But you get it running for a longer and longer period of time. I would consider that a win. That's a definite win. But as you can see, the truth be told, if I can just find my freaking thing here. This is 15. Yeah, man, it's going slower. Pretty fast. 358. 358. So, I'm just thinking that one coil there is getting in the way. That off coil. It isn't adding anything. It's actually slowing it down. So we'll do 25 volts. Look at the spikes on that thing now. That is amazing. Yeah, 358 RPM. Hi, Trapper. What's up, man? $4.58. I'm not trying to do. Listen, man. We're trying to do stuff that isn't being done, not stuff that everybody else is doing. I mean, the trigger coils are like. So I mean, is this, Mr. Jake? Is this coming from your head? I would like a suggestion from your head, like something that you would like to see, not something that you have seen. And I mean, honestly, I don't understand what timing is. Hello. I don't understand it. I mean, I do the best I can and just, hook it up with the magnet or not on the magnet, and I hope for the best. And what does that mean? I'm sorry, I'm so sorry. Separate your sense coils. Is that like saying unhook, separate the gauges? I mean, you could be nice and like tell me to redo it from the start or something like that. 48, 489. I've had this thing going way faster than this. Talking about this one? Yeah, the base is being triggered from an interior strand in all of these coils. They all got their own trigger. So you're telling me to take up more space on the rotor alright, I understand now. I get it. But this isn't what you think it is. Yeah, Hall effect sensor, I could definitely do that with a Hall effect sensor. And I know this thing will work like time and a half better with a Hall effect sensor. What about putting the trigger coils that are here now into the drive and then hooking it all to a Hall effect sensor. But I mean, I do. I totally do, because they work so much better with the exterior trigger coil. Just an interior, and then taking it out of there basically and putting it over here and being able to move it around like that. Well, no. What I'm going to do is I'm going to hook up this Hall effect sensor over here. And we're going to go from there. How's that sound? Sound like a plan? Sure. Without a doubt, man. I can't normally get through the day. But this one is now spiking at, looks like about 900 sometimes. 900 volts through the collector. I don't understand how that's possible. It's like a peak voltage, spike voltage. Probably turn it down a little bit. It's at 25.2 volts. I think the spike's only like 700 peak voltage. But you guys want to see this hooked up to a Hall effect sensor, right? I just don't understand how the timing can be wrong on these coils, because they're not linked together. They're running. They all got their own timers. But you're right. I think the Hall effect sensor will work a lot better. Alright, so we need to hook the positive and the negative up, or the in and the out, whatever you want to call it. And then we got to hook the base. Now I see a small problem with just one Hall effect sensor, unless there's a way to have it when it's off, affect the off position. But I know that if I hook these all back up on their 120 degrees, that it'll work like magic. Unless I blow the frickin' sorry. I'm really, really sorry. Mr. Jake, you're brilliant. Thank you very much. You too, Peter. Great, man. Great, great. The more you guys converse, the more I learn, actually. Now, I think this is good within like 24 volts. I don't know. I forget its threshold. All right. Now, would it be advantageous to leave this trigger strand in as offset, and then have the other two, the two onset ones, be triggered by the Hall effect sensor? I don't know. I think I'm going to move it back is what I'm going to do. Because I think I've done all this already, like once or twice. All right, so just need to hook up the bases now. I need to transfer all the trigger strands to the Hall effect, and then I can use those trigger strands to generate electricity for other purposes. And that'll be great. I need to get a diode. This is the wrong kind of diode. I know I got one lying around here somewhere. I'll just use this one. I don't have enough clips. There we go. So basically, what you're saying is that the coil trigger strand is not timed right for good induction. All right, let's plug this in. What am I not doing right here? Any ideas what I could be doing wrong? Yeah, it's not working. I don't get it. All right, so if it's consensus, there's only one thing to do. Just take it all apart. Start over from the beginning. Yeah, it's not that easy for me to see it, so I just like to take it all apart. But look at it spin though. I mean, it's almost like it's picking up speed sometimes. I know that's not what is what's happening, but it looks like it sometimes. While I'm breaking it down, does anybody want to see any different rotors up here? I got a 14-inch. I've got a 6-inch. 14-inch has 12 magnets. The 6-inch has 4 magnets. Oh, I got a great idea. Since I'm like starting from scratch here real quick, I'm going to set up one of these coils, just one of them, in parallel. So, unfortunately, I don't think it'll be any less wired. It'll be 3 transistors. It'll be less a trigger string, though. That would be neat. You can get it to go with the Hall effect. And I move forward like I gave a wheat cheese heap. You know what I'm saying? All right, I'm going to put these off camera. When I deal with this, it's not going to be something that everybody's going to want to see.
Dad, the tick spider's way inside here. Dad,
What's that?
the ticks come in here?
No, not right now. He's asking me if the cat wants to come in. Can the cat come in? All right.
Can the cat come in?
There it is. The bare bones. And we're going to try with the Hall effect. And we're going to use this resistor. 100 volt, 20 watt. Oh no, 100 watt, 200 ohms, 5%. All right. But here, we're going to hook this up in a parallel fashion, just this one coil. We don't need this right now. I thought it was working really good. I'm just saying. And I'm glad that I can hook it up that way again if I need to. I thought the trigger strands were working good. I knew it could be better. It's just a lot. When I hear that, I'm like, yada. Because, I mean, just other ways that you can rearrange the coils, it all adds up to about the same RPM. But when you work with the triggers and the switches, you can take the same amount of power, a little bit more power, and get more RPMs. See, I'm working with transistors right now, and I've got transistors that work better than the ones I was using before, and you can tell. Okay, now collectors. See, it's still moving. I love it, man. It's like got really awesome capabilities for continuous motion, just not perpetual. And I figured since we're starting over, we might as well just go one experiment at a time. Because I mean, when you're in mid build and then you switch it and it doesn't work, there's really only one thing to do that won't waste a bunch of time. And that's to start over. I do it all the time. Smokey over here does it all the time. You know what? He doesn't get all bent out of shape about it. It's like, oh, oops. And it's not like a Jurassic Park oops, where he's like, what do you mean oops? And I was like, oh, my bad. Let's start over. If I've gained anything significant from doing what I've done so far, that's patience. I got a little bit more patience than I had before. And I had a lot of patience anyway. But I like using switches, so you can have two circuits built and have one run and then one turn on. That would be really cool. Like turn on as soon as it gets like a high enough frequency, enough voltage for, like to run a MOSFET when you know that it's not built for that. So you run it for what it is built for, and you have that connected to the MOSFET via an on-off switch or a toggle switch. All right, so now we need the Hall effect sensor. All the ones that I'm connecting to the power distribution, I want to be alligator, like the larger clips, because they clamp harder. Don't want any power problems. Still moving. I mean, dang. But none of that motion could generate any electricity. That's your material is more sensitive than copper. So we are hooking up the power of the Hall effect sensor, the positive and the negative. Didn't look like we did much, but we put the negative in and then positive. All right, and now we get these, get it looking nice and neat too, I guess. Plug in the base, and it's going to go through the resistor. Wait a minute. All right. I mean, basic communication is take the trigger strand out of the coil so you can move it around. Basic communication. Still moving. You get one more clip. And the 3 for the emitters. So I'll get those now. This is just one coil hookup for parallel. But this is going to be, I'm going to wrap it up here. And 3. right, so there's that. See if this yeah, I think we got action. I can see the Hall effect blinking. Nice. All right, so let me mess around with that a little bit without these headsets on. I want to hold this. I gotta jerry rig something real quick. All right. Thank you very much, ladies and gentlemen. Peace out.